every time when I say proportion, you must put in percentage. Huh? Okay, that is the rule. Calculation in any otherwise, that is afterward I will tell you. So every time when you see the word proportion, count the proportion or whatsoever in the question, first thing you remember you have to put in percentage. So proportion means part of one whole. That is called proportion. So that means proportion, the percentage, if in percentage form, so proportion we always use P. So if in percentage form, it will be 100%, the highest, and 0% is the lowest. Okay, so that is the thing that you have to remember whenever you talk about proportion. And another thing you have to remember is if I put in a number, highest is 1, lowest is 0. So proportion will never be more than 1, will never be less than 0. Okay, so these are the things about proportion that you have to remember. Can I not? So I'm going to talk about part F, 9F and 9E. 9E I will talk about later. Okay, next week. Okay, so for 9F, we want to talk about is, I'm going to give you a scenario. Okay, for example, I ask this question, what proportion you all like to eat gummy bear or not?
Yes.
Why? You can chew, correct?
Yes.
Yeah. But I don't. I don't eat gummy bear. In boxes. So I know there are 150 gummy boxes of 150. When I say boxes of 150, that means each box contains 150 gummy bear, okay? What proportion is green? Or should I put green? What proportion? One single thing, right? Is green. Okay, so now, how am I going to do that? I don't know. No one tell me. Okay, I never go and count before. So how am I going to judge?
We see, do we do probability? Like how many
How do you
different,
do probability?
like we see like how many total different type of colors the gummy bear could be. Like if it says like 5
I
different
don't care.
colors.
I just want to know green. Green or not green only. I just want to know the proportion of green only. Other color, I'm not interested.
If it's
What
like 5,
proportion of gummy bear in the boxes of 150 gummy bears are green? That means a company produce a gummy bear. So the company can claim, oh, I got 30% of my gummy bears are green. In this box, 30% of them are green. So how are you going to justify this claim? So how are you going to justify this claim? Like we justify the claim of the mean, correct? So now how are you going to justify this? How are you going to find this proportion? Or if I turn this as a claim, someone claim, okay, or the company claim that, okay, claim that 30% of the gummy bear are green. So how are you going to justify this claim? Pastor, you should know already. So how are you going to justify this claim? Pastor, tell me. Someone tell me already. Good. So we are going to take a sample, right? We are going to take a sample. Okay, so we're going to take a sample. So the first step is, the first step is you go and collect a sample. So that means I go and buy a box. I go and buy a box. Okay, I go and buy a box. Okay, so I go and count the number of green gummy bear. So this is a procedure. You see, another is a procedure. Bears in a box. Okay, so now I got that. So the result I get. So this is my result. Okay, 57 are green. I purposely write in green. So whatever I get here is we call it the, so if I put 57 divided by 150, so this one in here, we call it the X, okay. And 150 is the sample size. Okay, so now if I put 57 divided by 150, so what I get is, this is called, can I say this is a proportion of the population?
No.
No. So what do we call this?
Proportion of sample.
Proportion of sample. So we call this is sample proportion. And how do we write proportion for any? So this proportion always represent with the symbol P. Remember our small letter P. So sample proportion, we write a letter P, we let it wear a hat.
Miss,
So this,
I don't understand. There are a total of 150 gummy bears in the whole box, right? Then why is the sample also 150?
each box is a sample.
So what's the population?
The population are all the boxes of gummy bear produced by this company.
Okay. Okay.
Do you get me? Okay,
Yeah,
so
okay.
any other query? So this is the sample proportion, okay? So is the sample proportion normally distributed? We don't know. So we have to go to the powerful. So we have to go to the powerful theorem. So what is that powerful theorem?
Yeah.
And go by the terms of rule. So remember, so proportion, definitely the population is not normally distributed. Definitely no, because when you talk about proportion of green, that means you had only two outcomes. Either is green or no green. So this population, if I plot the distribution of the population, it will be like proportion. This is green. And the other one is not green, correct? You only have two situations. It definitely cannot be normally distributed. Am I right? So according to central limit theorem, this is not normally distributed, the sample size have to be more than what? 30. But for proportion, we have another criteria. Listen here carefully. We have another criteria. So this is my population distribution. When you talk about proportion, that means it's talking about discrete. Okay, so now, according to central limit theorem, this n must be more than 30. So we have the n is 150. Fair. Right? Hello? So, but for proportion, we have to have another thing. That is another criteria, remember? That is your NP must be greater than 5 and NQ must also be greater than 5. So now let's check. We don't have the population proportion, correct? So we use this as our point estimator.
Okay, Miss, why is it 180?
150. That is 5. Sorry. My handwriting. Sorry for bad handwriting. 150. Can I not? Okay, so now we check. So N is 150. So we check the first one. NP. So it's 150 times 57 over 150. So we got 57. Okay, fair, more than 5. And both must satisfy NQ. So this is 150 times. Okay, Q is 1 minus P, correct? Because you have only 2 situations. Either is green or no green. So the number of not green is, well, I take my handphone. I should take my calculator. 150 minus 57. Okay. So this is for us to check. So this is 93. Yeah. So this is another criteria. Make sure it is true. So if the n is not greater than 30, then you have to check for this. Okay, so that means my sampling distribution is normally distributed. Yeah. So now, how am I going to count? How am I going to predict? Okay, if I ask you to find the 95% confidence interval for the true proportion of gummy bears that are green. Okay, so how to find? So we go to our calculator. I try not to give you the formula first, because the formula can be very confusing, okay? So go same. What you do is take out your graphic calculator, go to stack, go test. Okay, you tell me which one to select. See whether you can tell me which is the one or not. Go down. Number one is Z test. Where got proportion there?
Oh, what I mean is the one prop Z test.
Cannot. That is Z test. I want confidence interval. I want to have the word interval. Z interval cannot. Z interval is to predict the true population mean. Faster, tell me.
Is it the one prop Z interval?
Yes, you have the one prop Z interval, correct? That is
Oh,
A.
it's written in my textbook here.
Yeah, lo. I ask you not to look at the textbook. I ask you to look at the calculator. Try to interpret the calculator, what the calculator is telling you. One prop, that means one proportion. You see there is talking about two proportion, so test, we are not talking about test, we are talking about interval. So you go to A, 1 prop Z interval. Okay, why we call it a Z interval? Because we are depending on the Z score. Later, I will tell you how it go, okay? We try not to let the formula confuse us first. Okay, so now you go into there. Everyone get into there?
Mm-hmm.
One prop Z interval? Yeah. Can you tell me what are the two things that you're supposed to enter? Three things.
X,
X,
population,
X, no, where got population?
wait, N,
Yeah. X, then N,
and the confidence level.
then the confidence level. Do you know what is the value for these three number for this situation? Okay, can someone tell me what is X? Okay, now I start from the bottom. Okay, Zahara.
57.
Yeah, 57, good. Then you continue to give me the N.
150.
150, confidence level?
0.95.
0.95. So this is much easier than confidence interval for true population mean, correct? Yeah, so now what do you get? You know, your number cannot be more than 1, cannot be less than 0.
0.30.
0.30, some more?
30232.
30232. And the highest?
0.45768.
Okay, so how are we going to put in words? Still remember how you put the mean in words? You put the same way. But please remember, you put in words must be in percentage.
Me?
Anyone? Yeah, okay. You can try. That will be good.
We are 95% confident
That
that the true population mean of the gummy bears
are what color? What color?
green. Oh, they are green.
Ah,
Sorry, they
ah,
are green.
can be as low
as 0.3.
Cannot, must be in percentage.
Oh, sorry, 30%.
30.2%.
And as high as 45.77%.
Yeah. See, Anna? So it's the same. So what you need to remember is you need to remember this one. And you need to remember when you talk about proportion. That's it. So your sample proportion is your point estimator. Then from there, you use your calculator, one prop Z interval to predict. Yeah. So the way you write will be, we are 95% confident that the true proportion of gummy bear that are green can go as low as 0. You see, I also made the mistake, 30.2% and as high as 45.8%. So this will be your confidence interval. Yep. So if someone claim that, okay, if the company claim that in a box, there are a box of 150 gummy bears, proportion of green is 40%, then we have insufficient evidence to reject the claim. If the person say at least 30%, then we also can say. So if the claim, someone claim, okay, at least 30% of the gummy bear in boxes of 150 is green. So how are you going to justify with this claim? So how you justify? You tell me how you justify. Can someone give me the justification for this claim? So I say I try start from the bottom. If not, Yu Xuan or Yi Xuan? Yi Xuan. Is it?
Yeah.
Okay. Yi Xuan, try.
We have sufficient evidence to we have insufficient evidence to reject the claim, as the confidence interval for the true proportion lie. Oh, wait, what?
Wait. I wait. Everyone need times to analyze.
We have sufficient evidence to reject the claim that at least 30% of the gummy bears in boxes of 150 are green, because the confidence interval for the true proportion, the lowest value is 30.2%, which is greater than 30%.
Good. Excellent. So you know. Are you okay? So you just read out the claim. We have insufficient evidence to reject the claim that said at least 30% of the gummy bears in boxes of 150 are green, because the lowest possible proportion from the confidence interval is 30.2%, which is more than 30%.
Wait, insufficient info to reject or accept?
I don't reject lah. Insufficient evidence to reject. To reject, you write down the claim. That means you don't reject the claim. This evidence doesn't allow you to reject the claim. That is the meaning of insufficient evidence to reject, because we don't want to use the word accept. ACCEPT. Yeah, I don't want to say I say it's true. It's not 100% true. So try not to use that word. You understand or not? This evidence say I don't reject. The next evidence maybe I will reject. Do you get me? Okay, for example, now I get another sample proportion. Okay, then I got the sample proportion. Okay, the X is X over N, so it's still 150. And this one I get 40 only. Okay, for example. So what is my confidence interval for true population proportion? Now you go and calculate and see how you go. Then I will tell you how. What do you mean by insufficient evidence and sufficient evidence to reject? Okay, can you please calculate? Ah,
Same.
okay, can you please calculate? Okay. Email, what is the answer? Email? Hey, you all forgot my rule already. Email? A good friend of email, you all better text email. Yes, email. Tell me what is the confidence interval for true population proportion. Okay, your mic is not working. I can't hear you. Okay. Domain error. Where got domain error? What? Anyone got domain error?
No.
No, I got this. Can someone verify my answer?
Yes, I got that too.
Yeah, me too.
Same, got that as well.
Okay, thank you. Right? So now, if based on this evidence, okay, Wei Shen, you try. Based on this evidence, this is called the evidence. So now based on this evidence, okay, so now how are you going to justify the claim? Hello? My claim is at least 30%. Wei Shen.
Wei Shen or Wen Shen?
Wei Shen.
Oh,
You. Wei Shen.
okay. Sorry, I thought you were calling someone else. We have sufficient info to accept the claim.
Don't use the word AD. We have sufficient evidence to reject the claim that say at least 30% of the gummy bears are green because the lowest predicted, if you don't, then I try to use the word to make you understand. Predicted true proportion. What am I writing? True proportions of, so you write down, I have to write down in gummy bears that are green is 19.6%, which is less than 30%. So that's why you have sufficient evidence to reject.
All right, I get it now.
You get it?
Mm-hmm.
So try to use sufficient evidence to reject. Evidence means the sample proportion that you get. So both mean and proportion, they are the same. It's just the calculation is different. How you justify the claim, everything is the same. Are you okay?
Yeah.
So we try not to get into the formula first. Next week only I get into the formula, then we talk about the margin of error and so on and so forth. Can or not? We make sure we get it right first. Are you okay?
Mm-hmm.
So we try to do one of the question in the exercise. Okay, so I'm not, you 9F.1. Okay, 9M.1, you should be able to do it quite okay. So we try to do one question on justify the claim, okay? Yeah, so can you please go to page 290. Let's try question 2. Okay, page 290, question 2. To test if a 6-sided dice was fair, it was rolled 150 times. Okay, 42 were recorded. 42 was recorded. Okay, so to be fair, that means, okay, fair dice. Fair die. DIE, DICE, the same, fair dice. Okay. The proportion here means that means if you roll the dice 6 times, 1 time you will get the 4. Correct? So P is proportion of 4. You put an S there. How many 4s you get? Right? You see what am I writing? Proportion of 4s. Okay, so now in this case, what is the sample size? You roll the dice 150 times, means the sample size is 150.
Yeah.
Okay, so what is the value of X?
Miss Do,
Hmm?
if it's a fair die, shouldn't the P be 1/6?
Hey, sorry, 1/6. What am I? Thank you. Okay, what is the X?
42.
42. Okay. So, can I find the confidence interval using my calculator? Will the proportion, sample proportion distribution, this is called sample. So my perimeter of interest is proportions of whether the dice is a fair dice or not, proportion of getting a 4. Okay, sample. So my sample proportion distribution is normally distributed. Because N is 150, which is greater than 30. All right? If it's not greater than 30, then you have to check with the other one. Okay? Still remember the other one? Okay, so good. So now, find the sample proportion. Okay, part A, the sample proportion that you want me to do is 42 over 150. Yeah, so you take the calculator, you calculate. This is to answer to the question, 42, clear. 42 divided by 150. So I get 0.28. So can I put as 0. Am I right?
Yes.
So I have to put 28%. I told you already, proportion always final answer in percentage. Yeah. Then after that, the question says, what will you expect the population proportion P to be if the die is a fair die? That one I answer already. I expect it to be 1/6. Yep. Right? So now you construct. So the answer is 1/6. Okay, which is you take out the calculator, always give them in percentage. That is 16.7%. Okay, so part C, construct the 95% confidence interval. Okay, so you will have two answers come out, then you say we are 95% confident that okay. Can someone calculate? So I'm going to call you again. Just want to make sure everyone know how to calculate, okay? If you don't know how to calculate, the whole SAT will gone also. Okay. Nga Shen Kang. Is it Gan? Gan Shen Kang. Or Nga? Okay. Shen Kang. Hey, no response. Here. Answer. Don't say here. Hello. You like that? I teach until 2022 also cannot finish teaching. Hurry up. Shen Kang. Okay, then you type on. Huh? Lagging weight. What to lag? You just type your answer to me. Why you go and find also excuses instead of just type? Okay, 0.208. The other end, 0.3518. Okay, so we are 95% confident that the true proportions of getting 4 can be as low as 20.8% and go as high as 35.2%. All right. So now this is your confidence interval, 0.208. You can take any value in between here, right up to here. Okay. Fair dice is 0.167. Okay, so now, can you please say whether this dice is a fair dice or not based on this evidence? Based on this confidence interval, will you say the dice is a fair dice? Hey, is it fair or unfair? So now it's up to you to say, Cindy, Xin Li. Xin Li. Cindy, can you please give me the to say whether dice is fair or not and back up your answer? Xin Li. Okay, please give me the answer. Don't tell me your mic not working again. Today weather look good. Oh. Even my friend say it may have a thunderstorm. So shouldn't have internet problem. Yep. Hello, Cindy. Quick. You never try, you never know. Then exam, you also don't know. Hello. Typing ah? Wen Jie.
Yes,
Wen
miss.
Jie. Wen Jie. Okay. Justify the claim.
We have insufficient evidence to
Hey. Don't say insufficient evidence. Hey. The question is this a fair dice? You just answer. Is or not?
No.
It is not a fair dice because
The lowest true proportion is higher than the probability.
we don't say probability lah. We always say proportion.
Oh, okay. Okay.
Okay, try. It is not a
It
fair
is not
dice.
fair. It is not fair dice because the lowest true proportion is higher than the
Fair dice proportion.
and the fair dice proportion.
Okay, so try to say the proportion of getting a 4,
Okay.
right?
Thank you. Thank you.
You try to say the proportion of getting a 4. Okay, so you say it is not a fair dice because the predicted proportion of getting a 4 when throwing a dice, the lowest value is 20.8%, which is higher than the proportion of a fair dice, which is 16.7%. Are you clear? Okay or not? Okay. So this is an unfair dice. Okay. The proportion of getting a 4 is higher than the fair dice proportion. Okay. That is how you work on that. So is there a similarity between that? The answer is a yes. So the important thing is, okay, you see, when you see whether the question is proportion or mean or not, the question definitely will tell you. They want to claim proportion or they want to claim the mean. So you have no confusion at all. Are you clear? So, but you have to remember, so you have to remember, jot down for proportion, what to use. What to key in. Okay, these are the important things. And how to write the claim. Go as low as 30.2%. percent. If you didn't put in percentage, I sure give you 0 mark. And as high as 45.8%. Are you clear? Okay, then you justify the claim, you look at the situation and you decide. Oh, it's here. So this one not supposed to be here. Okay? So you can illustrate your confidence interval. So I ask you, by logic, if I want to make the confidence interval narrower, so what should I do? If I want to make the confidence interval narrower, what should I do? Use a bigger sample size or smaller sample size? Bigger sample size. I increase the sample size. So the sample will be a better representation of the population. So that's why the confidence interval will be narrower. Okay, so the 95% confidence, 99% confidence level, then that will be your Z alpha over 2, the Z score. So everything will be the same. Okay? So anyone who want to try to understand the formula, please go and read it up. I see whether you can understand it by yourself or not. Okay, so the formula next week only I will discuss. Yep, and I just posted one of the question 10 and I do more than what the question wanted. I list down the population, I list down the parameter of interest, and so on and so forth. So hopefully that will give you a little bit of guidance how to write your folio when next week I discuss with you. Yep. During lecture, I will introduce the formula for true population proportion, the confidence interval. Then during the tutorial, I will discuss about the folio question. Okay? Can or not? So anyone, if you have any question that you like me to help you to solve, do so. I will try my best and I will try to give you a bit more information. Can or not? Okay. So important thing, go and find out the facts. What do you mean by the confidence level? What do you mean by sampling? Why we need to do sampling? This kind of things. What is the population? What is the parameter of interest? Okay. So the parameter of interest for us, this topic, correct, is only 2. It's only 2. Who can tell me what are the 2? Who can tell me what are the 2? Your parameter of interest. Uma. Today I teach one. Last Monday I taught you one.
Mean and proportion.
Yeah. So that is our parameter of interest. We want to make a prediction of the true population proportion. Proportion of what? I don't know. You have to depend on your scenario. Okay. And I want to make a prediction of the true population mean. Mean of what? Is your parameter of interest. So our parameter of interest is only 2 here. The true population, we want to make a prediction of the true population mean, or want to make a prediction on the true population proportion. Hello? So it's not that difficult to write the folio. 20% is a lot, I tell you. You can fail your all your SAT, but you can write the folio properly. You get a B or A, then you can pass the whole 70%. So I'm here to help you. So you have to help yourself. Okay. So got time, go and read up a little bit. And if you look at the chapter under the confidence interval, correct? Actually, I've uploaded a lot of reading material and also some of the questions for you to try. You can go and try from there. Are you okay? Okay, thank you.
Yes, Miss. Thank you, Miss.
Thank you.
Okay, miss.
Yeah, miss.
Thank you, Mr.
Thank you.